rational functions. Root word irrational is ratio, which means fractions, and that, you know, can be a little scary. But we also found out there's some really cool graphic with rational functions. So division is really unique. It really, I mean, if you just think the most basic division you could possibly get would be like 1 over x. And the first thing that has to strike you is, I can't put a 0 down there. Something goofy must happen just because there's a variable down there. And that's the reason we get our hyperbolas when we graph. And as we go through this chapter, we're going to talk about things called asymptotes, which we've talked about before, and how you can use those to figure out what's going to go on with a hyperbola. But some of the coolest graphs that we see will involve hyperbolas. A lot of times, I think of like Southwest, when you get a blanket from the Southwest, that kind of thing, you'll see a lot of patterns that have to do with hyperbolas when that happens. So we went through the whole inverse variation thing yesterday. And here's the deal. Inverse variation means we're dividing. No other type of variation that we're going to study in this class does division. The rest of them are multiplication. So when we see inverse variation, we need to think, hey, that's division. No matter what the other ones are called, they are multiplication. So inverse, division. The rest of them are good. Went through our little mulch problem here. Did some variation. And got to this point because yesterday was really just about the two basics. Either direct variation, which is multiplying two things together, or inverse variation, which is using division. But there's more than that out there. Like in geometry, you saw a lot of variation equations. So why did we stop at that time and tell you, no, this one's direct variation, this one's inverse? Because geometry is about the formulas. And we want you to be able to find the numbers. The perimeter of a square equals 4s. Now, look at that differently. Don't look at it as, oh, it's geometry. Give me a side length and boom, I'll get you the perimeter. Look at it as, is that direct or is that inverse? It's direct. It's multiplication. So this is a direct variation equation. And yeah, it's super direct. Somebody says, hey, the side is 3, boom, it's 12. You know, you've got the answer. Right? It's just multiplication. Volume of a cone. Yeah, this one gets forgotten a lot. Anybody memorize volumes? Cones and that stuff? Maybe? 1/3 area of the base times the height. I would love to call that direct variation. It's not, because it has more than 2 things over there on the right-hand side. And there's a special name when you have to use more than 2. Now, could I say V varies directly with both the area of the base and the height? Yes, and some books do. But they also let you know that this is called joint variation. You have more than 2 things that you're joining together by multiplying. So that is joint variation. Now, notice we're getting more letters. When we get more letters, there has to be a fancy name for that. So when one quantity varies with respect to 2 or more, so we're talking about 3, 4, 5, we will have something called a combined variation. Because we're combining things. Multiple variables, more than 2. We're going through this. But when one quantity varies directly, which means multiplies by 2 or more quantities, that gets that special name of joint variation. So notice, still haven't used the word division. Division is purely for inverse variation. Any other kinds that we see are multiplication. So really, we're going to do division inside these problems. So they'll be combined variations. So this is the volume of a cone varies jointly. Notice they had to say jointly because we've got a couple letters over there, but that's the H. With the area of the base and the height of the cone. In fact, we can do better than this. We can tell them the constant of variation has to be 1/3. Now think about that. Constant of variation. So last year, we didn't tell you it was the constant of variation. You just got, hey, it's 1/3 area of the base times height. But it is constant. The 1/3 doesn't change. For any cone, the 1/3 is there. It's just a part of the formula. So what we're going to do today is look at some combined variations. And yeah, they kind of look like word problems, but they're not bad. You know why? Because there's only one that does division and the rest of them are multiplication. What's the one that does division? Inverse. So if it says varies, you just stop for a second and say, hey, is it inverse? Should I divide? Or is it something else that it's multiplying? So I'm going to ignore this stuff over here for a second and read it and find out what it says. Z varies. Okay, well, right there. Z varies. Tells me it's going to be Z equals and some constant of variation. I don't know what yet, but we'll get there. Z varies jointly. Well, that's not inversely, so that's multiplication. Multiplied by X and Y. No, combine means you can mix them all up. Now, sometimes we don't use both of them at the same time. So sometimes you won't have both direct variation of multiplication and inverse variation in one problem. But jointly means multiply. Multiply all this stuff together. The only division is inverse. That's it. So the second one here says Z varies. So immediately I write Z equals K because any variation has to have a constant variation. Z varies jointly. Oh, that's multiplication. With X and Y. Uh-oh, there's more. Inversely, oh, that's my division one. With W. So that's a combined variation. Has both are jointly and are inversely. Go to the third one, and the third one says Z varies directly. So Z equals K. I'm thinking to myself directly, that's still multiplication. Directly with X, and inversely, oh, that's division. With the product WY. So when we're reading these off, we have to watch for inversely. That's the one where we have to divide. Otherwise, we're multiplying. Multiplying. So, we're going to get rocking. And you're going to need more time to write, because these are right up here as well, but I wanted to talk you through them instead of just looking at the answers and saying, oh, those are nice answers. Oh, here we go. This says, the number of bags of grass seed N needed to reseed a yard varies directly. Ooh, I stopped right there. N varies directly. That's multiplication. So N equals K times something. Now I'm looking for what's the something. With the area A to be seeded and inversely, ooh, that's division, with the weight W of a bag of seed. Now here's the problem. If I want to use that formula, I have to know what K is. Right now I don't. Right now I don't have a number for that. So my hope is they're going to give me information for all of the other three so that I can find K. And then I'll have a formula. So let's see. It says, if it takes 2 3-pound bags, oh good, N is 2, and the weight was 3, to seed an area of 3,600 square feet, well that's A, that's area. So I'm not even going to finish the sentence. That's what I needed to find K. So I'm going to do a little algebra, a little bit of math actually, and find K. So 3,600 divided by 3 is 1,200. And then I'm just going to have to divide both sides by 1,200, and I will have K, which is 1/600th. Well, isn't that a pleasant number? Now what I needed that for was my original formula. So what I have to do is go back up here to the red one and say to myself, self, I got this number, so I can put it in for K. That's what it was for. Now that was obnoxious. We don't have anything to do with that 1/600. That was the math that they gave us. But we're just going to leave it. N equals 1/600 times A over W. Because there was more to this problem. Let's see what they want us to find. It says, how many 3-pound bags will seed 9,000 square feet? Okay, so I need a place to put the 3, and I need a place to put the 9,000. So, yeah, this is weight right here. And this just becomes a punch it in problem. So the work on these comes at the beginning. Get yourself a nice formula, set it all up and find K, but in the end, then we're just going to be able to punch stuff in. So 1/600 times 9,000 and divided by 3. They're going to need 5 bags. There is 5 bags. Now that truly is the math that the garden centers expect you to do before you go in. Instead of, well, let's buy a bag and see how much it's going to cover, and then we'll try to come back later and get another bag. They prefer you bought all your stuff at once, right, Jackson? Yep. So, got it. Number 4. Let's take a peek. The number of bags of mulch you need to cover a planting area varies jointly with the area to be mulched in square feet and the depth of the mulch deep in feet. If you need 10 bags to mulch 120 square feet to a depth of 3 inches, how many bags do you need to mulch 200 square feet to a depth of 4 inches? Now, I would have loved to have been able to say, because you guys were answering and telling me what to do as I went through this. Go for it. But they put a trick in this one. So let's get as far as the trick, and then I think I can let you go. The number of bags of mulch, okay, that's N. Varies jointly. N equals K. Jointly means what? Multiply. Jointly with the area to be mulched, A, in square feet, and the depth of the mulch, D, in feet. Did you see inversely up there in there? Me neither. We don't need the mulch. It is cool. Well, not yet. If you need 10 bags, so where's the 10 going to go? 10 bags to mulch 120 square feet. Where does that go? And here's the trick. A depth of 3 inches. Why is that a trick? The rest of it is in feet. Can't stand it when they do that. So we have to make this 3/12, which is 1/4. They're messing with us. That's what they're doing. So this will give us 10 equals 30K, because a fourth of 1/20 is 30. Well, if we divide by 30, that's going to reduce really nice. What? So let's write our formula now. We have K. Let's plop it up here. So N equals 1/3 80. There's our formula. Now, you and your partner are going to do the second part of this, and you're not going to let them trick you. Remember, you can't put inches in. So think about the information they gave you, make it into feet, do your calculations. By the time I get you a candy partner, hopefully you'll have an answer that you can talk to them about. So this is where some of you have the partner that's been working on something else on their Chromebook because they're not doing what they were told today. And you'll have to say, "You're a slacker!" Oh, leave the good one in? Well, then I gotta take something else out. That was gonna be something somebody wants that ends up out. Alright, so put those back in. 4, 6, 8. are you doing?
It's good.
I'll save one for you, man. Oh, don't like chocolate. Oh, that sounds like it would hurt. Division I football has big guys. That would hurt.
Going Division One. Oh, look at this thing.
Japanese. Spanish.
Yep. Let's see. Where are my Rick Dum Dum suckers? Rick Dum Dum suckers? Or is this instead? Both, but use that for partner. All right, so Candy up in the air. Find your partner and go tell them what you did. They did.
Neck, are you moving?
Yeah. Is that this at Walmart?
Yeah, I think so.
Try mine. Is this the one I traded? Yeah.
You need to go with Allison. But there's going to be somebody, there were 3 Dum Dum suckers. Somebody. It's right here. Tell them what you did. Which gives us 4 over 12, which is 1/3. So n equals 1/3 times 200 times 1/3. 22.2 repeating or something, right? Well, like I said, if that's exactly the amount that you want, you shouldn't be going to get bags. You should go to a nursery where you can, shovel your own out and that kind of thing, and they'll measure it. But you did go to buy bags, so you'll have to buy 23 bags in order to make that happen. And it is really when you do the math wrong and you're out there doing a project and you're all sweaty and you thought you had enough stuff, and you look and you go, oh my gosh, we underestimated bags. Somebody's got to clean themselves up, go back and get more bags. It's an inconvenience. So better to know what you need up front. Now, this looks awful, but it is exactly the same type of thing that we were just doing, but with more words in it. It says gravitational potential energy, PE, is a measure of energy. You guys did this in science. PE varies directly. Oops, I stopped right there. PE varies directly means I have a PE equals K. Forrest, look.
So much. Put that much food. I did not put it down.
Math classroom, I believe you're juniors. Boss, I can't do that. Forrest put something down my shirt.
I didn't put anything down his shirt.
Directly, are we multiplying or dividing? Multiplying with its mass and its height in meters above the ground. Did you see any inversely? No inversely. It's all multiplication. Now, it does tell us, and we know this, instead of using K in this formula, they use G for gravity. So they're showing us it is possible to not have it be K all the time. Right, Carson? Nick, come on.
It was his.
All right, we got a skateboarder over here. It says the skateboarder has a mass of 58. So where do you suppose that goes? M. Skateboarder has a mass of 58 kilograms and a potential energy of 2273.6 joules. What is the gravitational potential energy, so we need G, of somebody else? Well, I can't tell them that unless I know the height. That's H. And it is in the picture. It's really bad, though. Can you even make it out that it's 4 meters in there. So now we can find G. That's what we need. We need G. So let's see. 58 times 4, 232. And if we divide both sides by 232, we should not be surprised by this result. Nine 9.8. Sound like gravity? With meters it is. So now we're going to put that back in our formula up here. PE equals 9.8 mH. And now we'll go answer whatever they want about the other guy. There's another person up here that weighs more. It says, what's the gravitational potential energy of a 65 kilogram skateboarder on the exact same apparatus? Which means it's still a 4 here. So, do that with your partner. Put the 65 in, put the 4 in, find out how many joules of energy. Check in with your partner, make sure you're getting the same amount of joules. I don't know, they're pretty sharp. Don't be running. I cannot imagine. I cannot imagine that. She must have had no sense of humor. Alrighty. PE equals 9.8 times 65 times 4. How many joules? 2,548 joules. Now, once you have the formula, let's punch it in. I mean, that's what it is. So if we can get our formulas set up, we're good to go. So let's set this one up. We have divers, and it says, how much potential energy would a 41 kilogram diver have standing on a 10-meter diving platform? I realize they didn't give us any new stuff to write a new formula, because we don't need a new formula. It's the same formula we were just using. PE, crazy. It is crazy, equals G times MH. With your partner, find out what you get for a 41 kilogram diver standing on a 10-meter diving platform. Find the joules. How many joules? 4,018 joules. Now, the picture in your note packet, I changed that because, I don't know if you know this, but this is Laura Ryan. She was actually a graduate. She was a student I had years ago from Elk River. She is diving for the U.S. Olympic team. So that's her. Laura Ryan from Elk River.
Kind of sounds like a
It does, doesn't it? Laura Ryan, it fits that stuff. B says we have an 80-kilogram diver that stands on a 6-meter diving platform. I really don't even keep reading because I'm thinking to myself, so PE equals 9.8 times 80 times 6. So that would give me what I need. It says at what height should a 40-kilogram diver stand to have equal potential energy? Oh, so I want to know when this 9.8 times 80 times 6 equals the next person. And the next person says at what height should a 40-kilogram diver? Okay, so I've got 9.8 and I've got 40, and they want to know the height. Well, that's not going to be a problem. I mean, we can punch this in and we can divide it by this. And look at each. So with your partner, do that. Punch all that good math in. See what you get. Make sure you tell your partner and label it. Label it. Labels are important. Going through this, what would the height be? But no, now come on. What's the only one we divide for? That's it. The rest of them are multiplication. So how high? 12 meters. 12 meters. So part B says, did you really need to do all the math on this? Well, the 9.8s we could have canceled out. We could have divided this by 40 and gotten 2, and then had 2 times 6 is 24. We could have gotten it without punching everything in what they're saying. And we could have. We could have. But kind of nice to be able to just punch things in for a change and not have to do a lot of thinking. So did that. All right, 43210 me on this. Even though it's word problems, kind of, it's not, right? Okay, so one more time. What's the only variation you use division for? That's it. The rest of them are multiplications. Thank your partner for their fine help.
Oh, well, there's one around there, but it's not open.
That's a lot of problems.
Word problems. We're not afraid of no stinking word problems.
I am.
You run screaming from the room.
Yes.
You don't need two. Yeah, it's like this. That will.
All right, there we go, everybody. The motto for today is get her done.